Okay, the first problem is saying that find the solution at x equal to 0 of this differential equation. So, whenever you see the problem statement like this, you got to define whether x0 is a ordinary point or singular point. Okay. In order to do that, we've got to find px and qx. To find px and qx, we've got to make the coefficient of the second derivative of y is equal to 1. So in that case, we will get this. So px is equal to 6 over 4x and qx is equal to minus 1 over 4x. So at x equal to 0 is a singular point or it is an ordinary point. X equal to 0. You plug 0 in here, can you find the value of px? Can you find the value of px when we put x is equal to 0 there? Can you find the value of px? No. So that means x equals 0 is a singular point. Now you know that in that case, the answer that we are going to assume can be summation of an x minus x0 to the power n. Because that one is just for the ordinary point. Now we know that our x equal to 0 is a singular point. So what we got to do next is just that we got to define the type of singular point, whether it is a regular or irregular point. If it is the case, if it is a regular point, so we can find the solution. If it is an irregular point, we can't find the solution. Now, in order to check whether x equal to 0 is a singular or non-singular point, we are going to use the criteria that x minus x0 px and x minus x0 where qx, right? Now, our x0 is equal to 0, so we would get x px. And our px is equal to 6 over 4x. So that means x equal to 0 could be regular singular point. Now we got to check the second case that now we are definitely sure that our x equal to 0 is a regular singular point. Now we got to find r, because we want to know whether it is in what case. Okay. So in that case, we know that we are going to assume y is equal to summation this is the solution. And we got to find r, and we got to know the value of r, then we would know that our answer will be in what case. Just 1, 2, or 3. You want to go over by placing the y to the differential equation and then get the initial equation. You can use the equation that I give to you. Okay, and that equation is and P0 is equal to limit x go to 0 x px qx is equal to 0. Then we plug P0 equal to 3 over 2 and Q0 is equal to 0 into the initial equation. And then find the value of R. So we got two value of R, I equal to 0 and I equal to minus 1 over 2. So which one is R1? R1 equal to 0 and R2 equal to minus 1 over 2. Now the differences between R1 and R2 is what? What is the difference between R1 and R2? 1 over 2. 1 over 2 is not an integer. So case 1. So in the case 1 it said that we have y1 equal to and y2 equal to this is Bn. So we have to answer y1 and y2. But we just can't answer like this because we don't know what is an and we don't know what is bn. So we got to find the recurrence relation of an and recurrence relation for bn. Whenever we know that too, then we would get the answer. Now our answer would be in the form of y equal to c1 y1 plus c2 y2, right? Whenever we know the a1, then an, then we know y1, and whenever we know the bn, then we know y2, and that would be it. So in order to get the recurrence relation, we've got to put the definition of y equal to summation of an times x minus x0 to the power of n. I'm sorry, minus 1 over 2. So in order to get the recurrence relation of V1, an and Bn, we've got to put this definition into the differential equation. Put r there. We don't need to put r1 or r2, just put r there. And then, because now we know r1 and r2, after we got that relationship, then we are going to place the value of r1 in there, we got an. And then we put the value of r2 in there, we got bn, something like that. Okay? So, we are going to plug this definition into our differential equation. But our differential equation, we have the second derivative of y, so we got to dip this 2 times. And the second derivative, like that. Okay, and then we put y and its derivative into our differential equation, so we will get a times x times summation of this plus this and minus y, which is summation equals 0. Now, we have x here. We combine this x with the x to the power n plus r minus 2. We would get 4 an n plus r n plus r minus x to the power n plus r minus 1, right? Because we have x here. We combine this x with this x. So that means we have x to the power 1 here, plus 1 there, minus 2 plus 1 equals to minus 1. We have three terms. Term 1 and 2 are the same. So we just put them together. We will get now we are going to shift. Now we just cannot combine these two terms together because the power of the x is still different. So we are going to do the shift of index, and we are going to shift this to be the n plus r minus 1. We are going to shift the second term to be x to the power n plus r minus 1. So that means we are going to replace the n of the second term with what? n minus 1. N minus 1, a n minus 1, x to the power n plus r minus 1. Minus summation n equal to 1 to infinity. We cannot combine these two terms together unless we make this n starting with the same one as the second term. So that means we are going to replace n equal to 0 for the first term, right? Because the second term starts with n equal to 1, but this one still n equal to 0. So we got to plug n equal to 0 into this term and then put the rest as a summation n equal to 1 to infinity, and then we can combine the first and the second term together. Now for the first term, if we plug n equal to 0, what would we get? 4a0 times r times r minus 1 plus 6a0 times r, the whole thing, times x to the power r minus 1 plus summation n equal to 1 till infinity. Just like that.